In this lesson, you'll be simulating a large storm. Be sure to start with the warm-up and activity 2, the reading and questions, before you begin the simulation. With the simulation, you'll be creating a few different weather events. We'll do the first one together if you need to see an example. We'll be using the Regional Weather 1 mode, so you can change it to that mode. And for all of the tests, we're going to be using surface water at level 5. So since the Galetown case study we've been using has a high surface water content because of the lake, we're going to turn up our surface water content to 5. Now, our first storm we want to create is a cloud with severe rain, so rainfall level 3. So I'm going to leave my sunlight to surface at a level 4. Let's run the sim. I can see energy from the sunlight reaching Earth's surface and being absorbed by the water. Now energy is being transferred to the air parcel, and some of that water is evaporating. I know that because water vapor is increasing. Once the air parcel is warm, it's less dense, so it starts to move up in the troposphere, where it transfers energy out and cools. We have a lot of condensation occurring. We can see a large cloud and rain falling. Let's analyze our data. Remember to wait for that rain to stop falling. So here's my starting and final temperature, my difference, and my energy. And I can see I've hit rainfall level 3, which is what we needed to do. So in my data table, I'm going to go ahead and fill this out. So the temperature of the troposphere where the parcel stops was negative 30 degrees Celsius. I notice it's the same as the final air parcel temperature. So they've reached equilibrium and the air parcel will no longer rise. Negative 30. And that's also the final parcel temperature. The parcel height, it's 6.5 kilometers. So pretty far above the ground where the air is cooler because there's less air molecules up there, less collisions. My starting parcel temperature, if I look back on here, starting parcel temperature is when it turns red. So 35 degrees Celsius. It also shows it over here. So the temperature difference is how much it changed, 65 degrees Celsius. And the energy transferred out, there it goes, was 168 megajoules. There we go. So your task then is to create a cloud with rain level 2 and a cloud with rain level 4, and to see what changes that might have led to Galetown's more severe weather. Once you're finished with the data table, go ahead and fill out the questions and then hand in your work. We're not completing activity 4, so the next task is to do the Ed puzzle on Google Classroom.